Hello everyone, welcome to my class, Math Lesson with Miss Kenny. This is video part 2, Quadratic Equations and Graph. You've learned about the shape of parabolas. Okay, now take a look at this. There are two parabolas here. The parabola on the left opens upwards and the parabola on the right opens downwards. So you can tell that the quadratic equation have a parabola or have a graph that opens upward just by looking at the coefficient of the x squared here. If the coefficient of the x squared is positive, then the graph opens upwards, just like when you smile, the shape of the mouth here. The mouth here, the shape looks like the shape of the parabola here. What about the graph on the right side here? The coefficient of the x squared is negative. It means the sad face. Look at the shape of the mouth. It looks like the graph opens downwards. Okay, that's how you remember about the shape just by looking at the quadratic equation. Okay, let's learn about the parts of the graphs here. Okay, there are these 2 points here. We call this x-intercepts. Is when the graph cuts the x-axis. Other name for x-intercepts, the other name is root. Okay, so this is root, the first root, the second root. Okay, and the line of symmetry here divides the base. Okay, the base is measured from the first x-intercept or the first root to the second x-intercept or the second root here. So the line of symmetry divides the base into 2 equal parts. Okay, this is the minimum point, or the turning point lies on the line of symmetry here. This is the minimum point, and this is the y-intercept. You've learned about this. Okay, the y-intercept is when the graph cuts the y-axis. The same with the graph on the right side here. These 2 points are x-intercepts. The other name for x-intercepts is roots, just like in square roots. So the x-intercept is when the graph cuts the x-axis. Okay, and this is line of symmetry. Line of symmetry divides the base. The base is measured from the first x-intercept, the x-intercept on the left, to the x-intercept on the right, the second one. The line of symmetry divides the base into 2 equal parts. This is the line of symmetry, and this is the turning point or the maximum point. The maximum point lies on the line of symmetry. And then this is y-intercept. Y-intercept is when the graph cuts the y-axis. Okay, this is parts of the graphs of quadratic equations. Now, the smaller the absolute value of a, the absolute value of a means the positive value. Okay, this is negative, right? What we meant with absolute value, it means the positive value, the a value only, not the negative sign. Okay, the smaller the absolute value of a, the wider the graph opens. And then the line of symmetry of the graph passes through its minimum or maximum point. Okay, obvious, right? And then the graph may have nothing, no x-intercept, 1 x-intercept, or 2 x-intercepts, but it has only 1 y-intercept. It always has 1 y-intercept. Okay, Now we will take a look at mathematical and real-life problems that involve the graphs of quadratic functions. Okay, let's take a look at this. Example, the height, y meters, of an object projected directly upwards from the ground can be modeled by y equals 45t minus 5t squared, where t is the time in seconds after it leaves the ground. Calculate the height of the object 5 seconds after it leaves the ground. At what time will the object strike the ground again? Find the maximum height of the object above the ground and the time at which this occurs. Okay, we are going to use a graphing software, a GeoGebra here. Okay, you need to open your browser and then find the website geogebra.org and then click Start Calculator. Here you'll get this appearance. Okay, another tab, a new tab here like this. Okay, you can start typing the equation using this keyboard here, the symbol here. Like, look at this symbol. You can click, it will appear like this. And you can start typing the quadratic equation. It was y equals 45x. We change the t into x because when we plot the graph on a Cartesian plane, we need to use the x-axis and y-axis. Okay, the y is obvious, the height, and the x is the t, the time. Okay, and after that, the GeoGebra will label the graph as f. F stands for function. See the graph, this is the graph. Okay, and after that, let's take a look at the question. Calculate the height of the object 5 seconds after it leaves the ground. It means the time, the t equals 5. Okay, t equals 5, it means x equals 5. Okay, type x equals 5 and then enter. The GeoGebra will automatically generate the label EQ1, this one, the straight line, the vertical line. Okay, and then click the point of intersection. Here you get the point of intersection 5, 100. This is the answer. Okay, so the answer for number 1 is 100 meters. The height of object 5 seconds after it leaves the ground is 100 meters. Please do not use the algebraic method or using substitution. So because from the previous assignment, I found some students using algebraic method, which is substitution. Substitute the t equals 5 into the equation. Okay, we are not going to use that. We are going to use the graphical method. If you're still using the algebraic method, then I'll reduce your score. Okay, next, the question. Okay, let's take a look at the question first. At what time will the object strike the ground again? The object will strike the ground again when the y, okay, the value of y equals 0. It means this is when the first time the object is launched, okay, or projected, and then this is when the object fall on the ground. Okay, this is the root here. Click until it shows root like this, 9, 0. So the object will strike the ground again 9 seconds after it leaves the ground. This is the answer for question B. What about question C? Find the maximum height of the object above the ground and the time at which this occurs. Okay, what you need to do, you need to click the maximum point. So the GeoGebra will show you extremum. Extremum is the turning point. The GeoGebra using the word extremum, and the same, extremum can be maximum or minimum. So the GeoGebra use extremum, or in other words, turning point. This is the turning point. The turning point is 4.5, 101.25. So the maximum height is the y coordinate. The time is the x coordinate. Time at which maximum height of object occurs equals 4.5 seconds. Okay, this is how we solve the quadratic equations using graphical method. Okay, thank you for watching Math Lesson with Miss Kenny.